Okay, let's get started. Thanks everybody for coming. Happy Thursday afternoon at TDX. Hope everybody's enjoyed the show so far. Thank you so much for coming to TDX, and thank you for coming to our session. We've called it Lightning Fast, Lightning Experiences. My name is Nate Hossner. I'm a senior product manager here at Salesforce. I look after list views and related lists, and I'm part of the performance improvement team here at Salesforce.
Hi everyone, my name is Ahmed Ghanem. I'm a director of product management here. I'm looking for Lex performance of that platform, Lightning Data Services. Looking forward to talking to you.
Great. Let's get started with everybody's favorite, the forward-looking statement. Please don't make any purchasing decisions based on anything that's not yet in market. Let's talk about this presentation. We haven't done this presentation at TDX or at Dreamforce before, but Ahmed and I wanted to get in front of our customers and talk about performance at Salesforce. So this is a little bit new. We're going to spend some time talking about how we understand the opportunity to make performance better at Salesforce, and we're going to talk about how we're going to measure this, how we're going to measure success, what we've done so far, because we've been at this in a concentrated way for at least a year, and then we're going to share with you our investments for the foreseeable future, at least for the next year. And then at the end, we're going to get real practical with some of the things that you as administrators or org developers can do to give yourself the best chance at delivering your users the best performance that you can with Salesforce. So let's talk about this opportunity. For those of you that use the idea exchange, you've probably seen this idea floating around because it's been floating around for several years. It's got 66,000 points. It essentially says, let's speed up Lightning, please. You've called it Lightning, let's make it lightning fast. And so Ahmed and I are here to, again, tell you we've heard you and share with you what our plans are for making lightning fast. And in fact, just to drive home the point, when we asked our customers last year to prioritize our features for the roadmap, this was the top vote getter, is lightning performance of all things, not an individual functional feature, but just overall performance. So let's talk a little bit about how we understand performance and what we're doing about it.
So before we dig deeper into how to understand performance, we first need to define what is the metrics we're using to measure it. So we're going to use EBT. So EBT is a Salesforce-defined metric, which is called experience page time, and it's basically identifies it's kind of a heuristic metric that defines how long it takes before the page is interactive. It's kind of the conservative side, so it's usually the page might be more interactive for the user from the user perspective before the EBT is actually finalized, so the EBT is usually bigger than the interaction time, but it's still a heuristic. So for doing that, we currently define an activity on the page. So EBT keeps going on until there is no more activity. And no more activity is defined in three aspects. The first one, is there any more pending requests going back to the server? If yes, then the EBT is still counting. Is there a request going to the client to get data from the local storage? And the last one, EBT is interrupted if a user does an interaction with the page. For example, the user clicked on a button, then the EBT is measured now as finalized. So what does this really look like from a user perspective? So first of all, we're going to talk about something called first page view. So first page view means here, for example, you opened an email, you click the link that's taking you to a Salesforce page. So you're typing a URL or clicking a link. Here's the URL. So once you do that, you get into this white page where there is a logo, and you're waiting for that logo, and then the experience change. And this part of the app, we're calling it bootstrapping the app. We're getting the app ready. Loading some components, getting the code to compile it, and so on. And then the next part is it gets into this blue screen where you're waiting for every part of the page to be loaded and rendered. And this is called the data and page construction. So from the user perspective, the EBT until the page is loaded. And from the user perspective, EBT is basically from the time he clicked on the link until the page is fully constructed and he's able to interact with it. Now, if you look into second page perspective, which means you're already in the first page, you went in there and clicked the button, for example, that goes you into the second page, you will see that there's no longer the construction, the bootstrapping part. There's no longer dancing, bears or anything like that. You're just getting into a page where you're seeing data getting constructed, and this is what the EBT is measured like. So When we look at EBT, we see that EBT has multiple drivers for it, and the biggest drivers which we expect is the same for everyone, is the more components you have in a page, you're expecting your page to be slower. This is no-brainer. The other thing is the more customization you're adding to your flexi page and so on, it's gonna lead the page to be loading slower. And then geolocation is a big factor in impacting the EBT. So for example, if your servers are in USA and your users are in Europe, or they are somewhere in Asia or EMEA, then certainly it's gonna be slower experience for them than if the user is in very near to the server. Last thing is org-specific optimization. Things enabled specifically in the org can certainly improve or degrade EBT. So as we define the metric, the next step for us is what do we want to focus on to improve the performance and measure our success. And we started in there by digging deeper into our user experience and how they're using our platform. So the first thing we looked into is what percentage of our users are using Salesforce from desktop versus mobile. And we found like nearly 90% of our users are using from desktop. So that means we should be focusing first in desktop as our metric of success, improving their performance. That doesn't mean that mobile is not improved, it's just how we are measuring our success. And then the second one is what is the different home records they are going from. So the record home, object home. You'll see in here that others is like 35%. So the first question is like, others seems too high, so why we're not focusing on it? Others is really composed of like more than 10 things that are less than 3% each. So looking at this, you can see that record home is nearly an order of magnitude from percentage perspective, more than all the others. And this is why we focused in our performance on record home experience. Last thing, when we talk about first page view and second page view, we want first to discuss what does this mean. So a user session starts when he goes to a new tab. So for example, when you are in your email and you clicked and it goes to a new tab, or you click on a Salesforce page and click open a new tab, this is considered a session. And this basically, the first page you're seeing there is called the first page view. This page will always have the bootstrapping part of it. And of course, the experience with Bootstrap will differ versus, this is a really stale browser. This is the first time you're opening your browser, because then everything is loaded from the server, versus you have been working already all day. So a lot of data is cached already in the browser components, and everything is already in the browser cache. So the experience will be much faster. But then the second page view is basically you're using console in Salesforce, so you're opening new tabs inside, or you're staying in the same page and clicking around and going to some other things. So you're in opportunities and you clicked in there and so on. This is called second page view. So we went into our statistics and looked how many of our page views are actually first page views versus second page views. And you'll see here that Woburn percentage, 90% nearly are second page plus views. So second page plus means they are doing second, third, fourth, fifth, all of these are counted in there. But the other interesting statistics is 50% of our sessions are actually only first page view. That means a user opened the page, did something in there, didn't go anywhere, just read in it, and just closed that session, so close that tab. So that means we cannot just focus on second page view and say, hey, we're tackling it. We have to focus on both first and second page view. So this is what we're doing. We're focusing on first and second page views experience. And we're using the standard in the industry of P75 as our measure of success, where we are improving the P75 EBT experience for our users. So once we define the problem, the next step is we have been working, as Nate said, for the last year in this. So what have we delivered for the last year? So this is a quick overview. It doesn't cover everything. I would suggest reading the blog posts and other information in there to learn exactly all the other things that has been going on. But we have defined 4 key investment areas. So if you think of a page rendering on the browser, you'll see there is 4 major things that are happening. First one is establishing a network connection. So there is establishing the connection, and we're trying to improve that. And so this is one of our pillars of improving performance, which is how do we increase the concurrency when we're establishing the connection to make our pages faster. The second one is the page starts loading code and compiling it, and starts going to the process of rendering. So this is basically how do we make sure we're shipping as less code as possible and as fast as possible, so the page is getting into the process of rendering and getting data. as we're rendering the page, there is optimization, layouts, different components coming in, and this is the third part of our page, which is rendering the initial page and also presenting the complete page. Last part is components, of course, are requesting data from the server. So how do we make sure we're prioritizing the critical data that needs to be loaded as early as possible, and having a way of figuring out which data is really important for our page to be rendered versus data that can wait later. So summarizing that, there's 4 key areas we're focusing on to try to improve. First is increasing concurrency, getting less code faster, optimizing layouts and components, and then prioritizing critical data and sooner. For each of these pillars, we're gonna talk about one feature in there with some details. So first one, increasing concurrency. So Salesforce has been using HTTP 1.1 in its load balancer and first-party servers. Hyperforce is in HTTP 2. But what that means is HTTP 1.1 has a limitation of 6 concurrent connections. And that means if you're trying to go into your page is trying to send more than 6 requests. For example, in this example, it's trying to send 8. 7 and 8 are gonna wait until some of these come back. So in this example, 4 and 5 came back before 7 and 8 that shipped. So Salesforce has been aware of this for a long time because HTTP 1.1 has been around. And what Salesforce did is basically do something called box guarding, which we're gonna talk about. But for HTTP 2, that limitation doesn't exist anymore. So we no longer have to wait for 6 and 7. They can actually be sent as soon as they are ready. And that means just switching and keeping everything as it is from HTTP 1.1 to HTTP 2 will give us some improvements in the pages that really have these XHR waiting for them. So what does box guarding do? So basically, Salesforce said, hey, I know that if we try to have more than 6, the page is gonna be much slower because all of these requests is gonna wait. So what does box guarding does is say, okay, all of these requests are coming inside the same tick. I'm just gonna combine them together and send them in one request. And that means in this scenario, instead of sending 8 requests, we're sending 3. One has 1, 2, and 3 in it. One has 4 and 5 and 6, and the other one has 7 and 8. The problem with that, of course, is if, for example, 6 is so slow in this example, 4 and 5 are not ready to be rendered or do anything until 6 actually comes back. So the experience now depends on what you got box guard with. So what did Salesforce do? We actually are, in summer 24, we're gonna have HTTP 2 on all our first-party servers. So everything will be on HTTP 2, and that also allows us to increase the number of concurrent connections from 6 to 12. Next thing is getting less code faster. So one thing that Salesforce allows our users to do is basically being able to edit their components, do changes to them, and ship them in production. So the only way for Salesforce to be shipping the latest component version that's available in production is to send first a request to the server saying, hey, what is the latest UID for this component? And once it gets that number, it then requests from the server that UID. Of course, in reality, we're not changing components every 15 minutes. So what we did there is said, okay, we're fully aware, we already sent that request to the latest to the server and it came back. We're gonna cache it in the browser. So that means within the time period of 15 minutes, if the user is requesting these components again, instead of going back to the server saying, hey, what is the latest version? It already had the latest version cached, and that means it avoided one extra round trip to the server. Next area is optimizing layouts and components.
Yeah, so I want to talk about components here. We are on a long-term migration path for our components, moving them up to Lightning Web Components, LWC. That's a more performant framework. Many of our components that you can use in Record Home are already on the Lightning Web component framework. The latest win that we've had here is Related Record. So Related Record is pretty widely used and has been on Aura until spring 24. This is a seamless update. So if you have Related Record in your Record Home today and you take the upgrade tomorrow, you're not gonna see any changes, but under the covers, we're running this component in the Lightning Web component framework, which is natively faster. And so what we've seen in our measurements so far is if you have this on a case Record Home, when you compare it to the old component, you get about 11% improvement in your page load times. So we have an ongoing roadmap of components as we're going component by component based on impact and volume of use to make these ongoing improvements.
So the last area I want to talk about is prioritizing critical data sooner. So one of the things we did in there is first we are going to define the problem again. So this is a Chrome trace from one of the pages of Salesforce. And what you see in there is you have all of these requests, components are trying to render and then requesting data. But if you look deeply into what's happening in here, you'll find there's actually kind of a waterfall happening in. So if you see the red marks in here, you'll see that once this component reached that stage, the first one, it actually sent the request back to the server, waited for it to come back before it started to render, and so on. And for this specific page, you'll see that we did that 9 HTTP requests that are actually serialized, sort of, that are happening after each other. And what that means is there's no way for this page to be loaded faster than this because each component is done and then it goes in there. So the only way for us to do that is to have these data that they were looking for already cached in the browser somehow. So one of the techniques we did in here is, one of the techniques we did in here is called prefetching. So what we do is at routing time, we know what entity the user is going to, and we know what kind of record fields they are usually requesting. So we fetch these as early as possible in the routing stage. So when they go into that stage of the component requesting the data, that data is already in the cache. So that doesn't really change the waterfall. The waterfall is still happening, but now the data is in the cache. He doesn't have to go, this client doesn't have to go back to the server to get the data. And this, of course, has shown significant improvements. It's coming. It should be already available in the spring for everyone. So next is we want to give some overview of future investment that are coming in this year. First one is improving our code delivery. So for any page to render, we need to have our code compiled and delivered. And one of the things that Salesforce has been doing is shipping this megabytes of data in the bootstrapping stage to make it possible to load the page as fast as possible without sending more and more requests back to the server saying, I need this component, I need this component. But one of the things we have been doing, because Salesforce has been supporting all these very old browsers, is they really were not very performant when you ship a lot of code of them. The browser really gets to a halt, it's very slow. So what we have been doing is actually shipping our code as text and then using eval in the browser to actually convert that and compile it. And that means that every time we do that, for second page, third page, and so on, whenever we're sending this bootstrap, we have to do the eval over again. But browsers has been really optimized in the few last years where there's something called bytecode caching, which enables the browser to say, okay, I know you need this code. I'm going to now save it compiled in my cache. So you don't have to recompile it again every time. And this takes effect from the second and third page. So what we're doing now is in 250, we are shipping the code to be shipped as JavaScript. That means it's already ready to be compiled. The browser now can start doing the bytecode caching optimization on that code by itself. Second thing is prioritizing critical data sooner. So we currently have, flexi pages has the ability to have multiple tabs. Salesforce is trying to always aggressively preload data as much as possible to make the user experience as seamless as possible. But that means also that we are loading data that's actually not in the default tab, which is the visible tab for the user. And that means all of this extra data in the tab is also getting loaded. So one of the things we're doing here is using progressive page rendering to enable us to say, okay, we're going to focus on the data on the default tab only. Everything in non-default is going to wait for later. And that should really help users that have a lot of tabs, especially if they have slower components on the non-default tabs. Other feature that's coming in is called predictive data loading. So this is sort of the complement of the one we talked about. So in here, a user visits a page, let's say he's going to the opportunities page, and he did something in it. And then after a while, he's going to go to another opportunity page. But since the opportunity page for his org is not going to really be different, it's probably the same components in there. It's probably going to ask for similar data, but different record ID, but the same records. So what we're doing there is from his first visit, we're going to save all his data requests into the browser cache. And now when he goes to this new page, we're just going to, at routing, send all of these requests, saying, I know that the user going to this opportunity will probably need all of that data. So again, this is another attempt of fixing the data waterfall, because now he doesn't have actually, again, to wait for these data to come back from the server.
And then one more we're really excited about, we're calling user agnostic flexi pages. So we'll show a waterfall on the next slide, but what we've realized is anytime a user loads a record page, we're going out from client to server and fetching the flexi page shape, right? So this is the shape of the record home. That's unnecessary. It adds a lot of time to the round trip. So the concept here is to generate a single flexi page for the org that then is shared by all the users. So when you look at this timeline or waterfall, you can see what we measured was about 20% of the time taken to load a record home, aka a flexi page, is spent doing this round trip to go get the flexi page shape. So we're gonna cache it and share it. This is rolling out for custom objects in the spring 24 release, and then we'll roll out to some of our bigger core objects in the summer release later this year. Again, this is a seamless update for our users, so you're not gonna see any change in functionality. You don't have to do anything to adopt it. Ideally, you'll see some snappier page load times as a result.
So this is a quick overview of our roadmap for summer 24 and winter 24. So summer 24, as mentioned, HTTP2 will be enabled everywhere. Predictive data loading is coming in there. The second one is code delivery improvements, things like code as code and other code delivery that are coming in. As Nate mentioned, user agnostic flexi pages is coming for custom objects in the summer. In winter, we're gonna be wrapping tabs and progressive page renders. And that enables us to be no longer loading the non-default tabs data. Other thing is continuing the work on user agnostic flexi pages and doing standard objects, and then better utilizing CDN. And Nate was gonna talk about how much CDN is really impactful for our JLocal customers. So last thing, this is if you want to learn about what the story is and what we have been talking about. So in March 2023, we had 2 blog posts, one talking about enabling CDN, which is content delivery network. And that really helps improve the performance for our users that are far away from the server. This is enabled by default for all new customers, but for old customers, there is work needed to enable it there. And then the second one is we shipped our first blog post talking about what is the Lightning experience, is it really fast as we hope it is or not. September, we sent the second blog post, which is talking about what are we doing for that year, which we shared with you. And then we had the TDX talk, and then expect another new blog post talking about future investment that's coming in March. Thank you.
Okay, so let's get down to some practical guidance here about best practices for performance. So you heard Ahmed talking about some of the enhancements we've made or are going to make. A lot of these are under the cover, right? These are caching strategies or data prefetching strategies. These are seamless to you as administrators and developers. You're gonna benefit from them without taking any action. Let's talk about the things that you can do to put yourself in a position to have the best possible performing record homes. So 3 concepts, Ahmed talked about this. The more components you have, the more fields you have, the more complex filters you have on your record home, the slower your page is gonna be. That's just a fact of life. And same for the initial tab, right? So if you have that initial tab loaded up with components, fields, et cetera, that is gonna be a drag on your performance, EBT times. And our roadmap is really targeted at the modern aspects of Salesforce record home. So LWC components and dynamic forms. That's where we're gonna be making investments at the UI layer. So those are 3 big concepts. What are the solutions? And I'm gonna go through a demo here in a second to show these. So if you're using the record detail component, we strongly suggest that you move over to dynamic forms. We strongly suggest that you assess your record homes and take anything that's not critical and put it on secondary tabs or 3rd, 4th, 5th tabs. And then also use conditional display to only show contextually what users need to see in terms of components, in terms of tabs, in terms of fields, right? So it's all about optimizing your record home, and you get 2 things out of it: better performance, and your users get the right information at the right time. So quick commercial for dynamic forms. This has been out in production for quite a while. It's really now coming to maturity. It is supported on nearly all of the standard objects that Salesforce has, along with all custom objects. This is easily composable by an administrator entirely within the Lightning App Builder. No need to use the page layout editor. And it's a great way to potentially retire old custom code that you've used in the past to accomplish some things that now dynamic forms can do. Retiring clumsy old custom code components may also speed up your performance. So that's a quick commercial for dynamic forms, and we'll talk a little bit more about it as well. If you've tried dynamic forms and there was something missing, rest assured we have a really robust roadmap for dynamic forms. We're doing a demo right out here at the Lightning App Builder booth for the rest of the day on the roadmap for dynamic forms. Conditional tab visibility is coming in summer 24 along with the blank space component. Those are two big asks from our customers who are trying to adopt dynamic forms and just haven't been able to. That's about 50,000 points of idea exchange. Also custom template. So if your record home has a custom template, if you've run up against this, you'll see you can't use dynamic forms with a custom template. We'll deliver that support in the winter release. So let's take a look at a demo here on how you can optimize your record home to take advantage of forthcoming perf improvements. So I'm on an account record home here, and I'm gonna bring this into the Lightning App Builder by hitting the Edit Page button. And if you haven't seen this before, this is the upgrade path for dynamic forms. So I'm looking at the old record detail component, and I get a prompt in the Lightning App Builder to upgrade to dynamic forms. And I can pick one of my existing page layouts to start from. This is just a starting point for the migration. And that is going to migrate me into dynamic forms. So now, rather than having this monolithic record detail component, I now have individual field sections and individual fields that I can manipulate. And by manipulate, I mean you can set UI behavior, you can easily drag and drop, and you also aren't limited to making this just a monolith. So for example, you can add tabs and move content across the tabs, which in prior components just wasn't possible. So for example, I can create an addresses tab and take this addresses field section and just drop it in here. Maybe. Oh, there it goes. Okay, and maybe further, maybe on addresses, I only want that to show up in certain cases. So maybe only when the record type equals reseller, maybe that's the only time when we really care about addresses. So what I'm showing right now is conditional tab visibility. This is in the summer 24 release. So now I've spread this out a bit, right? I've got related, I've got details, I've got addresses. Let's do something else. Let's go to create a system information tab. And again, I can pull this field section here with system information and put that in another tab. So this is a really simple example, right? You may be working with very complex and deep record homes, but imagine taking this simple example and extrapolating it to your particular use case using the power of dynamic forms and the promise of progressive page rendering, right? So all our focus is on what needs to be on that details tab, what's critical for our users on page load, and what's not critical, let's put it out on the other tabs, because when we deliver progressive page rendering, then you're gonna get a tremendous amount of savings by organizing your record home this way. So now I return to runtime, and we can see I've got the related and the details, which tells me I might need to refresh, but let's give this a try. I think I've lost my tab bar. At any rate, if I went back to the Lightning App Builder, again, you can see if you set your type to reseller and you have that conditional field set, then you're gonna show the proper tab and save yourself a lot of time. So that's just a quick demo, again, a real practical use case on how you can manage your record home to leverage our upcoming performance improvements. Second thing I want to talk about is CDN, Content Delivery Network. Like Ahmed said, this is an existing feature that all of our existing customers, all of our new customers are opted into by default, but we have a real lag with our existing customers. So we want to urge everybody as a best practice to enable CDN for your org. And you can see on the graphic here on the bottom, without CDN, you're just going straight server to client. That is a slower response time. With this distributed CDN network, this works particularly well for geographically distributed call centers and operation centers. You're gonna get faster times. So I've pulled this content on this slide right out of our blog post that Ahmed shared at the beginning, and we have a QR code for this at the end, by the way. What we're seeing is when an organization turns on CDN, they're getting a 15% average faster page load time for P75 EPT. So this is as easy as going into setup and searching for session settings and then clicking the button for Enable Content Delivery Network. But we do want to warn you, read the blog post, work with your IT team. You could have firewall rules or other restrictions that your organization implements that would prevent Salesforce from working correctly with this. So you want to jump through those hoops, but this is something we would strongly suggest as another actionable best practice. And then just hitting quickly on developers. So some real simple best practices for developers. We've talked about this. Aura components do not perform as quickly as LWC components. So if you're building something new and custom for your org, we highly recommend going with LWC. And not only that, you'll get our native out-of-the-box performance enhancements in the LWC framework. Again, we're not targeting any enhancements at Aura at this time. You'll always want to use Lightning Wire API adapters and functions. We have a better caching strategy. We've talked a lot in this session about caching, so you'll get that with Lightning Wire API adapters. And again, because it's out of the box, you're going to get our enhancements for performance as we go along. We also have trailheads, and I think we have links to this behind our QR code as well, where we have developer best practices and information about performance guardrails. So, wrapping up. Now what? If you scan this code, this will take you to the Trailblazer community where we've got a ton of information to follow up on what we've shown today. We have the blog post, so Ahmed shared the several blog posts that we've created this year. It has the CDN instructions that I just went over. We have a link to our product documentation about dynamic forms and how to enable those. And then we would love to hear feedback from you on specific challenges that your organization has with performance. Every organization is different. We take inspiration from the challenges that our customers have, and oftentimes we can roll that into our performance roadmap going forward. Ahmed, anything to say in closing?
No, thank you.
Okay, thanks everybody. We are happy to take questions off stage. Thank you everybody for coming.